Hello everyone. The previous video we went through the various angles associated with the sun-earth planes and also two phenomena known as beam radiation and diffuse radiation. We also saw the differences between them, and today we are going to see the measurements, how the solar radiations are measured using 2 meters. Okay, the 2 meters are more important. So for the measurement of solar radiation, as I said, we have 3 basic types: sunshine recorder, pyrheliometer and pyranometer. So first we look at the sunshine recorder. I think the diagram is very clearly self-explanatory. As you can see, you have a glass sphere with a support base and you have a grooved bowl with recording paper. Okay, so the solar radiation directly falls into your glass sphere and the grooved bowl helps in, because it is already given with the recording paper, to know the radiation directly. So it consists of a glass sphere of about 100 millimeter diameter and it is mounted concentrically in the spherical bowl with grooves. The axis is held parallel to the axis of the earth, so the sphere is acting as a lens, okay, and focuses the image of sun along a special thermal sensitive paper strip marked with a time scale. So whenever your radiation intensity is above 200 watts per meter square, it creates a burnt impression on the paper. Note that radiation intensity 200 watts per meter square. Now as the sun moves, a burnt image is created along the paper strip, indicating the bright sunshine periods along the strip. അപ്പോൾ അതിനുശേഷം ഈ ഒരു 200 വാട്ട് പെർ മീറ്റർ സ്ക്വയറിന് റെഫറൻസ് പീരീഡ് വെച്ചിട്ടുണ്ട്. അപ്പൊ തന്നെ പേപ്പറിലൊരു എന്താ പറയുക, ഒരു പുകഞ്ഞ പോലെ, ഒരു കരിഞ്ഞ പോലത്തെ ഒരു ഇംപ്രഷൻ വരും. അതിനുശേഷം ഈ സണ്ണ് മൂവ് ചെയ്യുന്നതിനനുസരിച്ച് എന്താവും, എപ്പോഴൊക്കെയാണോ നമ്മുടെ ബ്രൈറ്റ് പീരീഡ്സ് ഉള്ള, ബ്രൈറ്റ് സൺഷൈൻ പീരീഡ്സ് ഉള്ള ആ സമയത്തൊക്കെ ഒരു ബേൺഡ് ഇമേജ് വരും. ഓക്കെ, the sphere is supported in various fashions depending on the place of measurement, like polar, latitude, temperature or tropical. Okay. Next we go to the another meter, which is our pyranometer. So let's just have a look at the diagram first. Again, you have a glass is being used and the solar radiation is shown, diffuse radiation is shown, both direct and diffuse, and you have the glass hemispherical glass, the inner portion and the outer portion is shown, and in the middle you have a thermocouple that is attached to a blackened disc. Okay, so these are the parts of the pyranometer. So you can see a real instrument also. Everywhere I've tried to attach the image of the existing or used instrument as well. So it is useful for measuring the total radiation. Okay, this is not just total radiation, means beam plus diffuse. Okay, so it can also be used to measure only the diffuse radiation, for which a shading ring is to be used. So you can see when there is a shading ring used, it measures only the diffuse radiation, and if that is not there, you can use it for measuring the total radiation. So it can be used also to measure the diffuse radiation, for which a shading ring is to be used, so that the beam radiation reaching the sensor is prevented. And it consists of 2 hemispherical glass domes. A black strip is located inside the glass domes at the center. The sun's radiation is allowed to fall on the strip through the glass domes. The thermocouple is connected to the black surface at its bottom surface. All have seen whatever we've mentioned. Now as the temperature rises due to the absorption of solar radiation, the thermocouple develops a proportionate EMF, which forms a measure of the measured radiation with suitable calibration. You're already familiar with the process of thermocouple, which develops a EMF. So here also, whenever the temperature rises, the thermocouple will develop an EMF, so that forms a measure for the radiation. Okay, and the pyranometer can also measure the diffuse radiation from the sun. For this purpose, the instrument is located under a semicircular shading ring. The shading ring is arranged in such a fashion that its plane is parallel to the plane of the path of the sun's daily movement across the sky, and hence it shades the thermocouple and the 2 glass domes throughout the day. So you don't get the beam radiation is not measured, instrument can record only the diffuse radiation. The next instrument is the pyrheliometers, and this is used only for measuring the solar beam radiation. Okay, it collimates the radiation to determine the beam intensity as a function of the incident angle. So generally for this, thermoelectric transducers are used, and for measuring the direct solar radiation, it is important to place the receiving surface perpendicular to the direct solar rays. Now let's have a look at the instrument. The parts of the instrument have been given as 1 to 6. So let's see it. Part number 1 is the humidity indicator. Part number 2 is the sight. Part number 3 is the body of the meter instrument. 4th is the protection cap, means protection for the lens, okay. And 5th is the window with the heater, and 6th is the cable. Now let's see it's working. Sunlight enters the instrument through a window. Okay. It is directed onto a thermopile which converts the heat into an electrical signal, and this electrical signal can be recorded. The signal voltage is converted via a formula to measure the watts per square meter. Watts per meter square is radiation. So the electrical signal developed watts per meter square convert. It is used with a solar tracking system to keep the instrument aimed at the sun. So typical pyrheliometer measurement applications will include scientific meteorological and climatic observations, material testing research, and assessment of the efficiency of solar collectors and photovoltaic devices. So since we have seen both the instruments, let's just see what are the differences between them. So pyrheliometer is used for measuring the solar beam radiation. The pyranometer can be used for both total and diffuse radiation. And in pyrheliometers, a mechanical tilting arrangement is essential to move the sensor to follow the sun's rays, which means your ray has always to be perpendicular to the sensor plate. Okay, but in pyranometer, the sensor is kept at a constant position. Then in pyrheliometer, the aperture angle and the tracking mechanism may not be perfect, and it may induce errors. But a pyranometer doesn't have such problems. Okay. So we'll stop this lecture here and we'll continue with the next video. Thank you.